So in 3 dimensions, we also have our vectors where we can have left and right, back and forth, or you can think of east and west, north and south, but then you can also go up and down. So you've got your x-axis, your y-axis, and your z-axis. And so z sort of adds that third dimension of height and things like that to it. So here we've got how you would show x, y, and z on a 2-dimensional piece of paper. And if you had the vector -9, so basically what you do is you think of your x and your y-axis as in 2 dimensions. And you imagine that written on a piece of paper, and you put that piece of paper down on a desk. Can you see that still being a 90-degree there? And then you add the third dimension up in this way. So you've got -9 and 3. -9, 3 would be in 2 dimensions way over there. When that's laid down, you can see that point that way. And then from that point, we need to go 4 up. So we would go up 4. Now, whatever distance 4 up would be here, that same distance would have to show up 4 from that point, -9, 3. So we can kind of imagine a rectangular box there, and that vector would go from one diagonal to the other. Now we can find the length of that vector in a very similar way to we find the length of a 2-dimensional vector. Right? If you had -9, 3 over here and you wanted to find out how long that is, well, you would know this length is 9, this length is 3. A squared plus b squared equals c squared, and you would find out what this length right here would be the square root of 90. Similar, when you go to 3 dimensions, it's just the square root of all 3 of them. A squared plus b squared plus c squared equals d squared. Now the reason that works is, what did I find? When I went here and here, I could find this length, root 90, by doing a squared plus b squared equals c squared. And then, can you see that I would make a new triangle here? That would be right angled because it's straight up and down. And this part was square root of a squared plus b squared. And now you'd have to add this. So you're just using a squared plus b squared equals c squared again. And the effect of that would just be squaring all 3 of them and adding them up. So it's a pretty nice formula. So if we wanted to find the magnitude, -9 squared plus 3 squared plus 4 squared, square root of 106. So I'm going to get you to try these ones. Find out how long each of those are. All right, what did you get for the first one? The length of u is 5. The length of v square root of 75, or 5 square root of 3. And for c, the length of a is perfectly 7. Nice. That's a pretty vector. Yes. Right, the nice ones like 3, 4, 5. Is there? I don't know if there probably is some nice patterns to finding out what 3-dimensional ones work out to whole numbers like this last one that equals 7. Which Could get us off topic for all class if we wanted to play around with that. I think there would be a lot more of them. More possibilities and combinations. Okay. Do we have a value for A yet? So setting this one up, we know that the length is 10. It has to equal 3 squared plus A squared plus negative 7 squared. Squaring both sides, this would be 100 equals 9 plus A squared plus 49. Is it 42? And A is the square root of 42. Yes. Plus or minus. Because you would get that same length whether it was positive or negative.